Hey pre-calc, welcome back. Our objective today is going to be to solve polynomial inequalities both by hand and graphically. I've got the checklist on the screen. You know what to do from here. So you don't need to write anything yet, but in calculus we solve polynomial inequalities to reveal aspects of certain functions. So for example, after we do some calculus, we may need to analyze a function like what I have below. We may need to know where a function like this is positive or negative without looking at the graph, okay? So I'm going to force pause on your screen. I'd like for you to copy this function and then go ahead and hit continue. So what I'd first like to do is, let's see if we can find the zeros of this function. And what do I mean by zeros? I mean the x-intercept. So that's going to be for what x values make this function, make the y 0, right? So let's go factor. This is already nice and factored for us, which is good news. So let's go factor by factor. So let's take a look at this first factor. For what x values makes this factor 0? We can think about it, subtract 3, divide by 5, so this would be negative 3 divided by 5, or negative 5/3, right? And then let's take a look at the next factor. What x values makes this 0? Just 2, right? And then the last factor, what x value makes that factor 0? That'll be negative 4. So I've got these three x-intercepts, right? And what I'm going to do is show you the graph now and see when the function is positive, when it's negative, and what do we mean by all of that. So let's take a look at the graph. All right, so here's the graph of f of x. Notice that we do have x-intercepts at negative 4, negative 3/5, and positive 2, and those are the same ones we predicted from here, right? And however, notice that negative 3/5 our graph touches and turns, or you may have used the word bounce in Algebra 2, right? In other words, we don't cross over the x-axis. And why is that? Remember, that's because of the multiplicity of this factor is even. So I've got an even multiplicity, so it would be a multiplicity of like 2, 4, 6, 8. And so my function is going to touch the x-axis and then turn back around, okay? Now let's talk about what we mean by positive, by a function being positive or negative. When we talk about a function being positive or negative, we're talking about its y values being positive or negative. So if I look from negative infinity to negative 4, this segment here, then my function values are all positive or negative there? They are all positive. All the y values there are positive. Notice that this is different from increasing or decreasing, right? So it's above the x-axis, y values are positive. Okay, from negative 4 to negative 3/5, are your y values positive or negative? They're all negative. They're all below the x-axis. Let's see if I can do this better. So all negative y values there. What about from negative 3/5 to x equals 2, positive or negative y values? Negative y values, right, below the x-axis. And then what about from x equals 2 to infinity, positive or negative y values there? Positive y values, right? It's above the x-axis. So my function went from above the x-axis to below to above. So the y values, the function went positive, negative, positive. So yellow, green, yellow. So oftentimes we will make a number line to represent this. So I'm going to grab this number line here and force pause on your screen. Can you make a number line for me with just those three values that we got for the x-intercepts? All right, and if I want to make this number line to identify what we just got, then I would go, okay, from negative infinity to negative 4, it was positive, right? The graph was above the x-axis. From negative 4 to negative 3/5, it was negative. Negative 3/5 to 2, negative again. And then from 2 to infinity, we had positive y values, right? And so we're going to be using number lines like this to represent whether a function is positive or negative on certain intervals. And I do want you to notice again that it switched, our sign switched, from positive to negative at negative 4 and at 2, but it stayed the same at negative 3/5. Again, that has everything to do with this even multiplicity of 2. The others had understood odd multiplicity, right? Understood multiplicity was 1 there. So my multiplicity here is 1 as well. Now, why does it not cross with even multiplicities? Well, if you think of something squared, can something squared, a real number squared, ever be negative? It cannot. So if this piece is always positive, when I multiply by a positive number, it can't change signs, right? So if I have a positive times something else, then it's whatever that sign of that something else is going to remain the sign for the whole piece, okay? So I can't switch signs unless I start multiplying by a negative, and that's where these pieces with odd multiplicities are really going to come into play, because they have the ability to switch signs when you have a power of 1, 3, 5, 7, etc. Here we do not have the ability to switch signs. This piece is always going to be positive. First pause on your screen. Can you go ahead and copy the inequality that I have? All right, we're back. So what we're going to do is solve this inequality. We're going to do it by hand first and then also check graphically. The very first thing we're going to do, which our other one had already done for us, is factor. All right, so take a look at this trinomial here. And let's first always look for GCF first. And notice, okay, I can factor out an x, which is going to leave me with x squared minus 4x plus 4. Right, I'm going to go ahead and leave off this inequality for now. Now let's take a look at the trinomial. I've got x squared minus 4x plus 4. So think, okay, what multiplies to be 4 and adds to be negative 4? Well, that's going to be negative 2 and negative 2, right? So x minus 2 quantity squared. Okay, now I can go ahead and list my zeros. So look at factor by factor. Take a look at this factor first. When is this factor 0? When x is 0, right? Okay, now look at this factor. When is this factor 0? When x is positive 2, okay? So here's your next step. Now we're going to make a number line with just those values. So I just got 2 x-intercepts. Make your number line with only those 2 values on it, okay? So let's grab, here we go. So we've got 0 and 2. And now what we're going to do is come back. I would recommend boxing this factored form. And here's what I'm going to do. I'm going to test this very first interval, okay? So pick a number in this interval. Any number will work. I'm going to pick x equals -1. And what I'm going to do is test that value into this box right here, okay? So this will be -1, right? So that's going to be negative, and then this is going to be -3 squared, but if I square -3, it's ultimately going to be positive, right? A negative times a positive, is that going to be negative or positive? It's going to be negative. Notice that I don't care what the actual number is, I'm just looking for the sign. This is going to be true no matter what number you pick in this interval. You can test it if you don't believe me, okay? Pick a different number, see if it works. All right, now here's what I'm going to do. I could keep testing values, or I can use this trick of multiplicity, and I know that even multiplicities are going to switch signs or stay the same. They're going to stay the same. Odd multiplicities will change. Remember, O odd, O opposite. So I'm going to go to 0, take a look at my multiplicity. Is it even or odd? It's odd. So switch to positive or stay to negative? Switch to positive. Right? Okay, now the next value on my number line is a 2. So the 2 came from this factor here. Look at your multiplicity, even or odd? Even. So switch to negative or stay on positive? Stay on positive, right? Because even multiplicities, you stay the same. All right, let's take a look. So actually, let's solve the question. So we wanted to know where this function was greater than 0. Does that mean positive or negative? That would be positive, right? Greater than 0. So it'd be this interval as well as this interval. Now, would you want to include your x-intercepts or no? In this case, you would not, because notice you don't have that it's greater than or equal to, right? So we want strictly greater than 0. So my final answer is going to be these intervals 0 to 2 and 2 to infinity. You can use a comma here, or you can use the union symbol, right? Notice that I have parentheses, not brackets on either of these, because I don't want to include the x-intercepts. Again, that's because this is strictly greater than and not greater than or equal to. All right, let's take a look at the graph. So here's the graph. Notice again that I am above the x-axis, so y values are positive on this interval from 0 to 2, and this interval, oh boy, and this interval 2 to infinity. First pause on your screen, can you please copy the inequality? All right, we are back. So what is our very first step going to be? Very first step is to factor. And you always want to check for what first? See if you have a greatest common factor. Do we have a greatest common factor that we can factor out here? We sure do. It is 2, oh man, 2x, right? So get rid of that. So let's factor out a 2x, and that leaves me, so this 2 I factored out, so that leaves me with x squared minus 6x plus 9, right? And again, the goal is to get this into its linear factors. So I'm going to keep the 2x. Now take a look at this trinomial. So what multiplies to be 9 adds to be negative 6. That'll be negative 3 and negative 3, right? So x minus 3, or x minus 3 quantity squared. All right, let's take a look. Let's find our zeros now. So I'm going to go ahead and set this equal to 0. Find our x-intercepts. Go factor by factor. So 2x, that factor will be 0 when x is 0. And x minus 3, that factor is going to be 0 when x is what? Positive 3. Good. And let's just kind of think about the multiplicities. The multiplicity of at 0 is 1. And what about 3? That factor is going to have a multiplicity of 2. Okay, so just keep in mind our multiplicities there. I'm going to put an understood 1. All right, what's our next step? Next step is to make a number line, and just be sure that you are only putting in your x-intercept. So just 0 and 3 here. Now, you can test whatever interval you want. I usually just start with the first one. So what I'm going to do, let's come here, go ahead and box this factored form for me so you know where you're plugging this into, okay? And what I'm going to do is pick a number inside that first interval. So I'm going to pick negative 1 again. So I'm going to test x equals negative 1 here. When I plug it in, I get 2 times negative 1. So that's going to be negative 2. I'm just putting down the signs. Again, I don't care about the numbers. When I test x equals negative 1 for this factor, I get negative 1 minus 3, which is negative 4, but squared is going to give me a positive 16, right? So once again, I get a negative times a positive, which is what? That's a negative. Again, I would get a negative value no matter what number I picked inside this interval, okay? All right, now you could test another number, or you can kind of use this trick with multiplicities. So now I'm at x equals 0. That came from this factor here. Again, that had even or odd multiplicity. Odd, okay? So change to positive or keep to negative? Change to positive. O odd, O opposite. Now go to 3. 3 came from this factor here, which had what kind of multiplicity? Even, all right? So change to negative or keep to positive? Keep the positive, okay? So let's answer the question. We wanted to know where this graph was greater than or equal to 0. So would I be looking for my negative or my positive values? My positive, right? So this interval and this interval. And do we want to include the x-intercepts in this case? In this case we do, right? Because of the equal sign. So notice I can actually just go bracket 0 and then all the way to infinity, right? I want all those numbers. I don't need to skip 3 because of the equals to part here. All right, let's take a look at the graph. Again, this looks really good. Notice that my y values are positive here, and then they stay positive all the way from 0 to infinity. All right, go ahead and try example 3 on your own. Notice it's already factored for you, so you can jump to finding the x-intercepts and making your number line. Hit continue when you are ready to check your answer. All right, final answer is on the screen. I do want you to be really careful because all of this is hinging on you getting that first interval correct. So just be really mindful of that first interval. A good idea is to check a different interval with the different number to make sure that your number line looks right. So, all right, you all, that is all I have for today. Make sure you summarize in one sentence, and I'll see you all next time.